Watch the complete playlist on the app Pions. Download the app now.
Determine the current in each branch of the network shown. So first of all, let's focus on the batteries. In this given circuit, there are two batteries. One battery is over here 10 volt, another battery is over here 5 volt, right? So both the batteries will contribute to current. Now let's assume that the current leaving this battery is I1. Let me call this current as I1, and this current I1 which is leaving the battery must be equal to the current going back to the battery always. So if current leaving the battery is I1, the current going back to the battery must be I1, and this I1 is going up. Here I1 is coming out and some current is going out of I1 up, not the complete I1. So let's call this current as I2 because A point is a branch, or okay, it's a junction. Junction is a point where more than one wire will come and meet. So if I1 is coming out from here, or if some water is coming from here, and these are two pipes, one is going this side and one is going this side, then some part of the water will go up and some will go down. Correct? So if I1 is coming here towards A and I2 is going up towards B, then what is the remaining one going down? That will be I1 minus I2. I1 minus I2 is the current going from A to D. Correct? Now I2 is going here, and let's say the current coming out of the second battery is I3. Then what is the current going back to the battery? As usual, it should be I3. I3 is coming from here from 5 volt battery and going towards B. I2 is current coming from here and going towards B. Then what is the amount of current going downward? That will be the sum of I2 plus I3. That will be I2 plus I3. Done. Now, if I2 plus I3 is coming from B to C, why I2 plus I3? Because they both will add up at junction. That is junction rule. Okay. Current entering the junction should equal to the current leaving the junction. Now, if from B to C, I2 plus I3 is going, out of which I1 is heading towards back to the battery here, then what is the current going down? The current going down will be I2 plus I3 minus I1. Let me repeat again. The current coming from B to C is I2 plus I3, and current going from C to A is I1. So current going from C to D will be I2 plus I3 minus I1. And if it is coming from C to D, okay, from C to D, how much current is coming? I2 plus I3 minus I1. And from A to D, current is coming I1 minus I2. So let's add plus I1 minus I2. You can see here I1 cancels with I1, I2 cancels with I2, and you left with I3. So basically what we left with? We left with current I3 which is going back to the battery, and our junction rule is satisfied. Let's start with loop rule. So how many batteries? Two batteries are there, and how many unknowns? Our unknowns are I1, I2 and I3. So minimum three equations we require to solve I1, I2 and I3. And if you need to solve these I1, I2 and I3, you have to consider how many loops? Three different loops. Let me consider the first loop. Okay. So loop I am considering A, B, C, A. I hope all of you can locate this loop A, B, C, A. You start with A, you go to B, go to C, and back to A. Correct? This first letter here in the loop and the last letter should be same always. Let's start with the battery. Is there any battery in the loop? Yes, 10 volt battery. So let me write it on the left hand side. And all other components and all other batteries, okay, batteries I am keeping always on the left hand side, everything else on the right hand side. So 10, why sir this 10 is positive? Because I consider that my loop I am going from positive terminal to back to the negative terminal. So I always go from positive of the battery to negative. Clear? Now be very careful. I am going from A to B. Look at this. I am going from A to B. Current is also going from A to B. Yes. If it is so, then only we will write a positive value. So 8 times I2. Let me repeat again. 8 is the resistance in this branch AB into current I2. 8 times I2, that will be our current times resistance is our voltage. Correct? Since I am also going in the same direction and current is also going in the same direction, so we both are positive. Now let's go to B to C. I am going from B to C. Current is also going from B to C. Yes. Is there any resistance? Yes, 4 ohm. So resistance plus, why plus? Because we both are in the same direction. 4 into resistance into current. Current is how much? I2 plus I3. Now I am going from C to A and current is also going from C to A. We both are in the same direction. So again plus. What is the resistance? 2 ohm and current I1. So 2I1. Let's simplify it a little bit before we consider the second loop. So 8I2 and 4I2. 12I2 plus 4I3 plus 2 times I1. This is our equation number 1. Let's consider our second loop. Again, I am repeating, I will always go from positive of the loop to negative. So these arrows you can make in exams which tells us in which direction you are moving. Your direction may not be in the same direction with the current. So be very careful. So A, I am going to D, I am going to C, and I am again going to A. A, D, C, A. Correct? Okay. Now in this loop, is there any battery? Yes, 10. Sir, what if I am going from the negative terminal to positive? In that case, this 10 will be written as negative, not positive. Clear? So 10 will be equals to A to D. I am going from A to D. Current is also going from A to D? Yes. So we resistance into what's the current in A to D? I1 minus I2. The next D to C. Sir, I am going from D to C. Be very careful here. I am going from D to C. Sir, how do you know that? Look at this. I have written the loop. I am going from D to C, but current is coming from C to D. You can look at the arrow of the direction here when we applied the junction rule. Now, since I am in the opposite direction to the direction of current, there will be a negative sign of resistance into current. Current is how much? I2 plus I3 minus I1. Now I am going from C to A. So final I am going from C to A. And is there any current? Yes. So resistance is 2 ohm and current is I1. So do we have to consider again this? Yes. Sir, we have already done. You have to consider when you are considering the loop. Let's simplify it. 8I1 minus and minus plus 4. 8I1 plus 4I1. 12I1. 8I2 minus 8I2 and minus 4 minus 12I2. Then done. Minus 4I3. Wait, there is plus 2I1 also. Okay, we will write that later on. So minus 4I3 and 2I1 is already left. So 12 plus 2, 14I1 minus 12I2 minus 4I3, and that's our second equation. Great. Now we need one more equation. Can't we, sir, solve these two equations simultaneously? No. Why can't you solve the two equations simultaneously? Because there are three variables and two equations. You can never solve them. Okay. So let's move to the third loop. So concentrate. Let's assume that this is E written over here in the 5-volt battery loop. So E, B, C, D, E. In this loop, is there any battery? Yes, 5-volt battery is there. And this 5-volt battery, let's start with, because I have taken from positive to negative terminal. So I am going from E to B, and current is also going from E to B, but there is no resistor. So you don't have to consider this I3. Sir, why don't we have to consider this I3? Because if there is no resistor, you won't be able to multiply resistance with the current and there won't be voltage here, because left hand side of the equation is voltage, right hand side everything should be voltage. You can see the previous equation, resistance into current, voltage, resistance into current, voltage, and so on, and left hand side also volt. But since here there is no component, no resistor or no capacitor, you don't have to consider that. Let's move from E to B is done. Let's move from B to C. Is there any resistor? Yes, sir. 4 ohm and current I2 plus I3 across it. C to D, yes, sir. 4 ohm and we both are in the same direction. And current I2 plus I3 minus I1. So this will be 5 equals 4I2 plus 4I3 plus 4I2 plus 4I3 minus 4I1. So from the first equation, 10 equal to 12i2. Let me go in the order 2i1, 12i2 and 4i3. So 2i1, 12i2, 4i3, and the battery voltage is 10. Let's reconfirm this. So it is 2i1 here, 12i2 and 4i3. That's only we have written here. Second equation, let me write here. Second equation is, let's start with I1, 14i1, 12i2 and 4i3. 14i1, 14i1, 12i2 and 4i3. Let's see if we have written it properly. So 14i1, 12i2 and 4i3. Third equation, which is over here, that is our minus 4i1, 8i2, 8i3. Minus 4i1, 8i2, 8i3. And battery voltage is 5. Let's reconfirm and then we will start solving this. Okay. So, sir, how to solve this three variable equation we have not done in 10th standard? In case if you don't know, let me remind you, very simple method, very simple technique. Many students, they try to remove or eliminate two variables at a time, but a better choice is first do the substitution one, right? So what I will do here is I will write 2i1 equals, I'm taking everything on the other side. So from the first equation, be very careful. 10 minus 12i2 minus 4i3, correct? And let's divide this 2 on the other side. So current I1 will be equals to 10 divided by 2. That will be 5 minus 6i2 and minus 2i3. This is our first one. We will require this, okay, later on. But right now, let's substitute this I1 in this equation and this both. Try to remember this thing, very important. You have to substitute it in both. Sir, why both? Why can't we do it in one? Because it will make the solution quite easy for you. How? We will see within a minute. So 10 equals 14 into I1. I1 is 5 minus 6i2 minus 2i3, correct? Minus 12i2 minus 4i3. From where we got this? From this equation we got it. So let's simplify it a little bit. So 10 equals to 14 into 5. 5 fours are 20, 70 minus 6 fours are 24 and 84i2 and 14 twos are 28i3 minus 12i2 minus 4i3, correct? Now let's simplify further. Let's take this 70 on the other side. It will be minus 60 and I2 is how much here? 12, and here it is 84. So it will be 4 to 6, 8, 1, 96 minus 96 I2 and I3 minus 32 I3, correct? All are negative. Let's remove all the negative signs to make it simple. And wait a minute, this is our I3. So this will become 96 I2 plus 32 I3, and here it is 60. This is our one of the simplified equation once we substitute I1. Let's simplify and put it in the second equation and simplify it. So this equation, it will take the form 5 equals minus 4 into I1. I1 is 5 minus 6 I2 minus 2 I3 and plus, one second, what happened? 2 I3 and plus 8 I2 plus 8 I3. Now 5 fours are 20, 24, be careful with the signs, minus plus 8i3 plus 8i2 plus 8i3. Now 24 and 8, let's take this 20 on the left hand side, it will become 25 because it's negative. When it goes on the left hand side, it will become positive. So 20 plus 5, 25. I2, 8i2 and 4, this will become 32i2 and 8 and 8, 16i3. I hope this is clear. This is our new equation. Now, what was the use of substituting this I1 in both the equations? When you substitute both the equations with I1, I1 gets eliminated and the new equations will be only in two variables. And linear equations in two variables become quite easy for you to simplify. I hope this is clear. So let's simplify it. Now here 32 and there it is 96 or here it is 32 and here it is 16. And let's multiply this second equation with 2 and subtract it with our first equation. So 25 into 2, 50, and this will be 2 to the 4, 2 3 is a 6, 64 I2, and 16 to the 32 I3. Let's subtract this one with that. So 60 equals 96 I2 plus 32 I3, and we can subtract it with minus 50 equals 64 I2 plus 32. So minus 32 I3 it is. I have written here by mistake I2. So this is I3 and this is also minus. So subtracting all, this will cancel out. 60 minus 50, 10. And 6 minus 4, 2. 9 minus 6, 32 I2. So what will be our current I2? Current I2 will be 10 upon 32. That will be nothing but 2 5s are 5 by 16 ampere. Correct. So, sir, we have found the value of I2. Now, how do you find the value of I3? By substituting either in this equation or this equation, because they are the equation in terms of I2 and I3. So, let's take the second one. So, here I am substituting straight away. So, 50 equals to 64 into 5 by 16 plus 32 I3. 16 4s are 64, 5 4s are 20. Let's take the 20 on the left hand side, equal to 32 I3. And 50 minus 20, 30 upon 32. That's our I3 value. 2 15s and 2 16s. So I3 value here is 15 by 16 ampere. Correct? We got our I2 and I3 values? Yes. Where we have to plug in now? You have to plug in over here. So when you plug in there, what will you get the value of I1? Let's substitute. So here it will be I1 will be equals to 5 minus 6 times I1. We have to find 6 times I2, sorry. That is 5 by 16, and minus 2 times I3, which is 5 by 16. 15 by 16, sorry. Now let's take the common LCM, 16 here. Here 16 5s are 80, 5 6 are 30, 15 2s are 30. That's I1. So 30 30 60, 80 minus 60, 20 upon 16. That you can write it as 2 10s and 2 8s, or we can divide by 4 5s and 4 4s. So current I1 will be nothing but 5 by 4 ampere. These are the values of I1, I2 and I3.
Watch the complete playlist on the app Pions. Download the app now.